Now today we are going to do section 9.5, which is talking about solving trigonometric equations. Now before we start here, please make sure that you know how to solve equations in general, which is done in chapter 2 of the book. Okay, in other words, it was taught back in algebra. All those skills of how to solve for x and that kind of stuff, you need to know that stuff inside out, because I'm not going to be explaining how the equation is solved. Okay, I'm just going to use those skills and solve it, and you are supposed to know what I'm doing. So if you have any trouble with that, please go over those parts again. Those parts, solving equations is a skill that you will use in math all the time from this point on, well, any point basically. So please make sure you know how to solve equations. So let's then start with example 1. This section doesn't have any new concepts really. We're just going to use what we learned about trigonometry and use it to solve equations. That's it. This is a very long section. Is worth about is basically about 2 sections combined. So please give yourself double the amount of time to go through this section or more. Okay, and that's just how it works out. Now, having said that, let's begin with example 1, which says find all possible exact solutions for the equation cosine theta equals to 2. So we have cosine theta equals to 2. What is theta? Sorry, not 2, 1/2. Now, when is cosine theta equals to 1/2? Well, first we have right here, okay, cosine is adjacent over hypotenuse, right? And this is 1/2. Now, which angle has adjacent over hypotenuse as 1/2? That will be the 60-degree angle, or pi/3, being the pi is 180. So then cosine theta equal to 1/2, then theta is going to be equals to pi/3. So that is our angle, pi/3, okay, or 60 degrees. That's the answer. That equals to theta. Now let's draw, but we're supposed to find all angles that satisfy this equation. To do that, let's draw this real quick. Here is pi/3, or 60 degrees, or cosine value of 60 degrees. That we'll write down 60 here, 60 degrees, which is equal to 1/2. The other value, notice that this is a positive value, positive 1/2, which means that the x value is positive. Okay. Now, what is the other possibility? Is this one, where x value is also positive, where the angle goes down this way. Okay. And this is in other words, this is negative 60 degrees. And for that one, the cosine also equal to positive 1/2. The reason is because cosine only cares about the x-axis. Okay, the hypotenuse doesn't have a sign. For the axis on this side, whether you go down or up, the x-axis is positive. Now, this angle going down, we can also calculate this thing as going clear around like this. In other words, this angle down here can also be called 2 pi minus pi/3. The whole angle, all 360 degrees is 2 pi. So coming all the way here is 2 pi minus pi/3, which is the same as saying 5 pi/3. Okay, so here are the 2 angles. This is equal to theta. That is, it could be pi/3 or it could be 5 pi/3. Now, if we are going to consider all solutions for it, then any of these angles, if we add 2 pi to it, that is, we go all the way around once first, and then get here. That would be the same angle, okay? Or we go all the way around twice, and then get here. That's also the same angle, because we end at the same spot. So then the solutions, all of the solutions will be counted as this. That is, theta equals to, we'll put a counter here. Okay, that is theta equals to pi/3 plus minus 2k pi, or theta equals to 5 pi/3 plus or minus 2k pi. And what is k? K is any number that is an integer. Then, well, anyway, yeah. Anyway, so So in other words, k can be 1, 2, 3, 5,000, 5 million, 50 billion, whatever. So those are all possible solutions, which means there's no end to solutions. But for the solutions that's contained within 0 to 2 pi, which is most of the time all we care about is from 0 to 2 pi, then pi over 3 and then 5 pi over 3 are the only two solutions within 0 to 2 pi. But if you allow all numbers, then the one that the book gives just means we're just going to keep winding around, and then you can have more solutions. Okay, so that is example 1. The next example works exactly the same way, which is sine of t equals to 1/2. So being that that's identical to example 1, please do example 2 yourself. Okay, and then we will move on to a different problem. Example 3. Solve the equation for between 0 and 2 pi for example 3. So let's consider this. Example 3 on the same page says we have 2 cosine theta minus 3 equals to minus 5. Seriously. All right, so let's solve for cosine theta like it is x. Okay, here's our little x. And we are going to solve for x. Then x will be equal to, sorry, not x. We want cosine theta. Cosine theta then equal to, we'll solve it as if it is x. Okay, so cosine theta will be equal to minus 5. Move the minus 3 over here, becomes plus 3. That becomes minus 2. Then divided by 2, then becomes minus 1. So cosine theta equals to minus 1. And what is theta? Now, if you draw the graph, okay, cosine theta equals to minus 1 is right here. In other words, your angle is called pi. And that's it. That is between 0 and 2 pi, that's the only angle that satisfies cosine theta equals to minus 1. That is the angle we need to go all the way right here. So theta then it equals to pi. And that's it. Theta equals to pi. And no other angle, then after that it's going to come back over here. So let's look at example 3. Yep, theta equals to pi on the next page. So that is that. Next, let's look at example 4 on the following page, where, let's see, we have 2 sine squared theta equals to minus 1 equal to 0. Now the trigonometric trigonometric equations often has more than one answer. In fact, it often have like 2 or 4 answers, and then sometimes depending on what they want, it can have infinite number of answers, which is what example 1 and example 2 are talking about. So in this case, being that we have a squared, then we're going to have more answers. So what is sine of theta? Sine of theta, move the 1 over there, that becomes positive 1 divided by 2, that's 1/2, okay? And then take the square root, that will be 1 over square root of 2. So sine, and then being that we take the square root, there's a plus or minus situation here. So sine theta can be 1 over square root of 2 or minus 1 over square root of 2. So what is theta? Now 1 over square root of 2 for sine theta is right here. See, there's square root of 2. That's kind of hard to read. Maybe I should do that. Okay. Now, so theta to be 1 over square root of 2, theta is 45 degrees, right? Opposite over hypotenuse. So theta is 45 degrees or pi over 4 because pi is 180. So theta equals to pi over 4 or 45 degrees. And in that case, but that's just one of the angles, okay? And so this is for sine theta equals to the positive 1 over square root of 2. If it's negative, then we have to think about something else. So for positive, but let's think about one thing at a time. Now for positive sine, this is pi over 2, and sine theta to be positive, then means the y value is positive because sine is opposite, which is the y, sine depends on the y value, see, up there. So that's for this to be positive, then these two angles, this one is the first one, and this one is the second one. These two angles will have positive values for sine theta, and that they both have the angle of pi over 4. Okay, the reference angle here is also pi over 4, and the sine is so opposite divided by hypotenuse. And therefore, the theta for the positive value is theta has to be equal to pi over 4, and that's the one we already have. And over here, which is 3 pi over 4. Okay, so because it's pi over 4, 2 pi over 4. This is pi over 4, 2 pi over 4, 3 pi over 4. And down here will be 4 pi over 4, which is pi. So these two are for sine theta equals the positive 1/2. Now if sine theta equals a negative 1/2, then it's the same thing except it's down here. Now for these two angles down here, that goes one of them goes all the way here, and then the other one goes all the way around. These two angles will have a negative 1 over negative. It will be negative 1 over square root of 2. So in those cases, then theta will be equal to down here, 4 pi. There will be 5 pi over 4, and that's this one, and then 6, 7. Okay, 7 pi over 4. That's for that one. So that has, so being that there's a squared situation here, the sine theta has 2 values, and then theta end up having 4 values to be able to satisfy this equation. So that's example 4. Next, let's consider example 5 after I clean off the board. So next, let's look at example 5. The example 5 is similar to example 4, except that they expect theta to go from 0 to 4 pi. So you have to repeat the angle. So please do that one yourself, and just remember to repeat the angle by adding 2 pi to your solution. Then you got 2 more answers. Next, let's consider example 6, where we have tangent theta minus pi over 2 is equal to 1, with theta between 0 and 2 pi. In other words, if your answer turns out to be theta equals to 2 pi, you throw it away, because we only care about theta that's less than 2 pi. If it's 2 pi or bigger, forget that. So anyway, so let's figure out what that is. First, what is theta minus pi over 2? Theta minus pi over 2 is satisfy the tangent of this thing equal to 1. So let's look at angle. The tangent is 1. It's the opposite divided by adjacent. That's the 45 degrees. Okay, so that means the theta minus pi over 2 is equals to 45 degrees, which is also pi over 4. So then, so that means theta equals to well, pi over 4 plus pi over 2. That is going to be equal to 3 pi over 4. That's one of the angles. And 3 pi over 4 is within this range. Okay, so this one's okay. But there will usually be another option. So tangent is positive, okay, is pi over 4. And let's see. So anyway, the tangent being positive is, of course, the positive angle here, pi over 4, or 45 degrees. Then y is positive, x is positive, so the tangent is positive, because tangent is equal to y over x. Now, however, there's another way that tangent can also be positive, and that is this angle right here. That is this angle here, where y is negative and x is also negative. So when they cancel each other out. So this tangent in this third quadrant is also positive. Therefore, here's your first answer, which is equal to pi over 4. The second answer is all the way down here. That is going to be equal to pi plus pi over 4 is what that angle is, which is 5 pi over 4. So the second angle is theta over this equal to 5 pi over 4, which is down here. See, these are sort of like technical details about trigonometry, and it can get rather tedious. Okay, to have to figure this stuff out, but there's no getting out of it. So please do this. So theta, that means, so if theta minus pi over 2 equals to 5 pi over 4, that means theta equals to 5 pi over 4 plus 2 pi over 4, which is 7 pi over 4. And 7 pi over 4 is still within the 2 pi requirement. So that should be, those two should be the two angles of theta. Equal to, so at the book says theta equals to 3 pi over 4 and 7 pi over 4. So we are good. And next, let's look at the next problem. All right. Now the next problem, example 7, please do this yourself, okay? It's similar to what we did. The equation solving is slightly more complex, not really. So we have tangent x on both sides of the equation. So you treat it as a variable. So we have two tangent x here, a tangent x on the other side, so that becomes one tangent x right here. And then we have a plus 3, throw it to the other side. So 5 minus 3, the plus 3 has to be multiplied by 2. So that's 6, throw it to the other side. 5 minus 6, that would be minus 1. Once you know that tangent x equal to 1, minus 1, then you know what to do. See, you just go ahead and calculate tangent x equal to positive 1, which is similar to the tangent x equal to minus 1 positive 1 situation. The minus 1 situation works about the same way. Okay, you figure out where tangent is negative, which is in the second and the fourth quadrant, and then crank out the answer, which is, again, a bit tedious, but that is just the way it is. For trigonometric equations, you usually have two angles. It depends on what range they want the solution on. And most of the time, you only require to get answers from 0 to 2 pi, but you always bear in mind that you can just spin around and there's actually keep going and there's an infinite amount of solutions. Okay, so next thing is, let's next look at example 8, where it says the sine theta equals to 0.8, where theta is in radians. Okay, so what is theta? If sine theta is 0.8, let me think. Why are they doing this? Let me think. So next, let's look at example 8 on page 871. Sine theta equals to 0.8. What's theta? Okay, that is not one of these convenient triangles that we've been working on, so we're going to pull this off with a handy calculator. The sine theta is 0.8, then theta is inverse sine, push shift sine of 0.8, and that should do it. And so theta is that, this is in degree mode, okay, and we will change it to radians, radian 4. Okay, sine theta, and now it is 0.92, which was 50-some degrees. All right, so theta equals to 0.9. Let's say theta equals to 0.927. Let's say that is that was 53 degrees or so. So then. Which is something like here, okay? This is theta. And as always, if theta is 0.927, which is in the first quadrant, then then what happens is that, then being that the sine value is positive, then there is another one that sine value is also positive, that is gonna be on this side, where the y value is positive. That is so theta equals 0.927, that's 1. The other solution is theta equals to pi minus 0.927. That's the other answer, okay? And that would be equal to, if we have this thing minus pi, minus, where's my pi there? That would be equal to, the other angle is 2.214. without the negative sign, because I did this angle minus pi. So anyway, pi is 3.14, so this minus that, it will be equal to 2.214, and that's the other angle, which has theta as the reference angle, and also has a sine value also equal to 0.8. So these two are the solutions for sine theta equal to 0.8. And of course, if you want to accept all other values as well, then you will have the 0.927, then you have a plus or minus 2 pi k added in, where k is any integer. That is 1, 2, 3, 4, and that just means you spin around every single time, and then you have infinite amount of solutions. Oh, and then the other solution is the same way. You see, if you flip over the page, next page, the other solution is 2.21, etc. And you always do the plus or minus 2 pi k business. That's if you want to include every single possible solution as you spin around and get here. So 2 pi, okay, get here again, and to 4 pi, or even spin it backwards. So the actual number of solutions is there are infinite number of solutions, but most of the time we only care about the ones that we spin once. Okay? There's no need to spin it too many times most of the time. So that is that. So please do those examples yourself to make sure that you understand why that is done that way. Next, let's look at example 9, which is something about secant and stuff. So please do example 9 yourself, since it's identical to example to the previous example, except that now it's just a secant instead of oh, by the way, being that it is secant, the calculator doesn't have secant, so you just have to translate it into cosine. That is, secant is 1 over cosine. Okay, we said right here, secant is 1 over cosine. So then if secant theta equals to minus 4 as given, then 1 over cosine is minus 4. Then you flip the fraction around both sides, then cosine theta is minus 1 over 4. And from there, then you solve for theta and stuff. So please do that yourself. Okay, that's example 9, and we'll move on to something, move on to the next page, where we have example 10. Example 10, then we have a trigonometric equation in quadratic form, where we have cosine squared theta plus 3 cosine theta minus 1 equal to 0. Oh boy. All right, so that, what happens there is now cosine theta is now your variable. So that's similar to the equation where if you consider cosine theta as your x, which is what we've been doing, right? So that equation translates into x squared plus 3x minus 1 equal to 0. So you need to solve for x. And the book doesn't really let you solve for x easily. And being that this equation is not solvable by hand, we have to pull out the good old quadratic formula. So by the time you're done with that, you end up with this extremely painful looking thing. And that is cosine theta equals to the plus 1 or the minus 1. And each one will come up with an answer for you. So then you will end up with, what are we looking for again? Theta, it goes from 0 to 2 pi. Let's see. So there shouldn't there be 4 answers or something? Let me see. Ah, that's right. Well, normally if cosine theta has 2 answers, then you should have, each theta will get 2 answers, so you should have 4 answers. But in this case, it doesn't happen that way, because the other option, where cosine theta equals to the minus option, okay, is too big. There's no solution for this, okay, because it's too big. Cosine only goes up to like 1 and minus 1, and this thing is like this thing is a lot bigger, or a lot more negative than minus 1. So you can throw that away. So you end up with only having to solve this one, and which calculate cosine theta equal to just one of the roots, which gives you 2 answers after messing around with it, like we've been doing. So that is so please do example 10 yourself. It is yeah, it forces you to pull out the quadratic formula, which is quite painful, but doable. Okay, so please do that, and we'll look at the next example 11. Example 11 is 2 sine. I think that is no different than example 10. Same story. You have a quadratic equation that you have to factor out. Once you factor it out, then your sine of theta will have 2 answers. See, there's the original quadratic equation, but at least this time you can factor it out, so you're not stuck with a quadratic formula. So this will make things look slightly more pleasant, not a lot, slightly. And with that, you can come up with sine theta. Well, if you're lucky, as in this case, sine theta equals to 3/2. That's not possible, because sine theta can only go from -1 to 1. So that's more than 1, so you can throw that one away. The other one, sine theta equal to 1, and that would be, there's only one possible for that. And that's theta equals to pi/2. Okay, there's nowhere else that sine theta equals to 1. So that is the answer for problem 11. Please do that yourself. Okay, it's not really that different, except that you have to pull out your old algebra and do factoring again. So there is simply some old work that's embedded in the new stuff, and the work from algebra is now embedded in trigonometry, and now you have to do both. All right. So, and then next, let's look at example 12. That is exactly the same thing. Okay, that is, so we have an equation which is another quadratic formula, but this one's easier yet. See, the book gave you the hardest problem example first, and then the next one's easier. This one is even easier, but this one doesn't have any rejects. That is, all the solutions for sine theta can work out. So you're going to end up with 4 answers, because sine theta will have 2 answers, and then each one will have 2 answers. And I mean, each theta will also have 2 answers. So please do example 12 yourself. And then let's move on to see, let's look at example 13 in the following page. What's this? Let's see. Yeah, I think this is the same thing. Quadratic form. I'm not seeing anything unusual here, so please do example 13 yourself. The same kind of story. Okay, you have some kind of a quadratic form situation. You factor it, and then sine theta will be equal to 2 things. So theta should have 4 answers. Well, except in this case, if sine theta equal to 1, theta has only 1 answer instead of 2 answers. So the total answers you have end up being 3. So please do example 13 yourself. And then let's move on to example 14. Example 14 is, yeah. Now we have a weird looking thing. And not that bad, okay? And this is similar to what we did in the previous section. You have a cosine plus sine. And that satisfies one of the formulas, and that equals to square root 3/2. So solving this thing from the previous section, that fits one of the formulas. So if you fit it into the formula, then everything will come out, and once it comes out, then you can solve it just fine. That is, the only hard part about this is turning this thing into that thing, and it turns into that thing by the formula we used in the previous sections. Which is in my other tablet here, which passed out. Let me wake it up. Okay, well, what are we doing here? Is cosine plus sine. Let's find it. Cosine plus sine. Yeah, right here, sum difference formulas. Here's my formula page, and you notice cosine plus sine right here. That's the cosine alpha minus beta thing. See? And so plug it right in here. That is cosine of alpha minus beta, which is, in this case, we have, see, cosine plus sine is equal to cosine of first one minus the second one, which is cosine negative x, which is just cosine x. So you're just doing cosine x equal to square root 3 over 2. What's cosine x is square root 3 over 2. That means theta equals to 30 degrees or pi over 6 plus the other angle, okay, whatever the other angle is. And that makes cosine positive. So that's example 14. So please do that yourself, and let's move on to example 15. Example 15 says we need cosine 2 theta equals to cosine theta. Now to do that, okay, we have to turn that into cosine theta. So there's an extra step here. So we have cosine 2 theta equals to cosine theta, and cosine 2 theta cannot directly cancel out with cosine theta, okay? You have to apply the special formula that beat it into cosine theta, that sort of thing. So let's look at our formulas that we learned in the previous section. And it has to change cosine 2 theta in some kind of cosine theta. So here's my formula chart, and look around here and see cosine 2 theta equals cosine squared theta minus sine squared theta. No, we're not going to use that one because there has a sine squared theta, which is in complication. Next one, just sine theta, no. And the next one, 2 cosine squared theta. Let's use that one right there. So we have the situation here, okay? We turned cosine 2 theta and following the formula to become 2 cosine squared theta minus 1, which equals to cosine theta. Now this is a quadratic formula. You rewrite this, factor it, and solve it into two solutions. Equals to minus 1/2 and then 1, and then each one will give you the two angles, except cosine theta equal to 1 only give you one angle. So you have 3 angles in your answer. So please do example 15 yourself. Next, let's look at example 16. Yeah, the example 16 we have 3 cosine theta plus 3 equals to 2 sine squared. And so these two things are different. So let's turn this into a cosine squared by using our trusted Pythagoras theorem in trigonometry. So we'll take this, replace sine with 1 minus cosine squared. That way everything is in terms of cosine, and then we can do the quadratic formula again, which is, if you turn to the next page, that is exactly what the book says. See, there's a sine squared. Let's turn it into 1 minus cosine squared, so that this whole thing becomes another quadratic formula that you have to factor out, and it gives you 2 solutions, and each one gives you 2 thetas. Well, except this case, cosine theta equal to minus 1, though it has only one solution. Theta has to be pi. And so we end up with just 3 solutions. So please do that yourself, all right? And let's look at the next one. Cosine 2x equal to 1/2. That one is not particularly exciting, because if cosine 2x equal to 1/2, then you can go ahead and calculate what it is. And because what is 2x? If cosine 2x equal to 1/2, that means 2x is 60 degrees, okay? Here's cosine equal to 1/2, right? Cosine of 60 is 1/2, adjacent over hypotenuse. If 2x is 60 degrees, then x is 30 degrees. That's the one angle, and then you have to find the other angle. So that's example 17. Please do that as part of your homework. And so next, let's look at example 18 on the following page. What are we doing here? Blah blah blah. There's a lot of talking, so let's read this amount of talking. I'm looking at example 18 on page 878. All right, so let's look at example 18 on page 878, right? And so it says, the problem is very wordy, but we're going to distill it down to the part that matters, okay? One of the cables that anchors the center of the London Eye Ferris wheel to the ground must be replaced. The center of the Ferris wheel is 69.5 above the ground. So that it says the center of the Ferris wheel. So it goes, so that thing is 69.5. All right. So that is that vertical line. And then the second anchor on the ground is 23 meters from the base of the Ferris wheel. So this line is 23. All right. And then that's it. So how long is this cable? So this is the cable we're talking about. And how do you find this? This is, of course, we'll call it C for cable. And of course, and this is the right angle right here. So what is C? Well, C would be equal to, of course, the Pythagoras theorem. This thing plus this thing and take the square root. Okay, C equal to square root of 69.5 squared plus 23 squared, and then take the square root, and that is C. And then the next thing they want to know is what is the angle of elevation, that is theta. And theta is equal to theta, it has two measurements here, opposite and adjacent. So theta, that opposite and adjacent is the tangent, okay? See, opposite over adjacent. So tangent of theta is going to be equal to 69.5 divided by 23. So with that, we can pull out our trusted calculator and crank it out. Let's do that, okay? So as you notice, the Ferris wheel is not relevant to our problem. It does that a lot. Let's see. All right. So let's see this. First, let's do the Pythagoras theorem. Why not? The Pythagoras theorem states we need the square root. And then parentheses. Do we need parentheses? Nah. 69. This calculator at this point doesn't need parentheses, I don't think. 69.5 squared. And then plus 23 squared. Okay, that's good. See, the square root is going over the whole thing, so I don't need parentheses. And that equals to 73.2. So C is 73.2. And let's see, I will, what am I doing? Where is C? What? No, wait a second. I'm at the wrong page or something. Where's the London Eye problem? Yep, 73.2. That is correct for C. Next, we have the angle. Okay, tangent theta is 69.5 over 23. So the angle theta will be inverse. I mean arctan, which I push right there. Okay, 69.5 divided by 23, and yeah. And that should do it. Close parentheses. That would be theta is 1.25, which if they probably want it in degrees. Okay, so if we shift it into degrees, which is 3, and do it again, 71 point something degrees. And is that what it says? That the degrees on the next page, 71.69. That is correct. Okay, so that is example 18. So next, let's look at some other thing. And the last example is example 19. There is there's a lot of words again. OSHA safety regulations require that the base of a ladder be placed 1 foot from the wall for every 4 feet of ladder length. That's the least you have. Well, I don't know if that's the least necessarily, but anyway. So you don't want to be too close, then, or else the thing might keel over. So then, anyway, find the angle a ladder of any length formed with the ground and the height at which the ladder touched the wall. The angle that a ladder, find the angle that a ladder forms with the ground. Okay, so we have, we just need the angle, right? It said so. It's 1 foot from the wall for every 4 feet of ladder length. Okay, so the ladder is, length is, the ladder is the one that's on the side. The ladder has to be 4. For everything here, that's 1. So across is 1. This is the right angle. So here's the angle. that we're looking for. And that will be cosine, see? So cosine of theta, has to be equal to 1 over 4. 1 over 4. So we just need to know what is the cosine, what the angle has to be. And to do that, let's calculate cosine. Now my calculator is in a degree mode, so let's do shift cosine of 1 over 4. That equals to 75 degrees. All right, so that's 75 degrees, and that is exactly correct. Okay, and that's that. See, that's that. We have now come to the end of this section. And I will assign homework in the next video.